The Atacama Desert in northern Chile. This desert, with its high mountains, plateau, and active volcanoes, is probably the driest place on Earth. This inhospitable terrain is where ESO, together with international partners, is building the world's largest astronomical project. The first of 66 state-of-the-art antennas has just been handed over to the project. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory, exploring the far reaches of the universe with our host, Dr. J, aka Dr. Joe Liske.
Hello and welcome to the ESOcast. In today's episode, we're going to travel to the site of Alma, the Atacama Large Millimeter and Submillimeter Array. This amazing new telescope is being built right now in the Chilean Andes at an altitude of 5,000 meters, high enough to be literally breathtaking.
Alma will initially comprise 66 high-precision antennas with the option to expand in the future. There will be an array of 50 12-meter antennas acting together as a single giant telescope, and a compact array composed of 7-meter and 12-meter diameter antenna built by Mitsubishi Electric Corporation for the National Astronomical Observatory of Japan. One of the Alma partners has just been handed over to the observatory. It will shortly be joined by North American and European antennas.
Each new antenna must meet very strict requirements. The surface of each dish must be accurate to the thickness of a human hair, and the pointing must be precise enough to pick out a golf ball at a distance of 15 kilometers. This antenna handover is a major milestone. The observatory team can now proceed to integrate the rest of the components, including the sensitive receivers that will collect the faint signals from space.
The antennas are tested at the Operations Support Facility at an altitude of 2,900 meters before being moved to the plateau of Chajnantor at 5,000 meters. The Operations Support Facility will also be the center of the observatory's scientific activities.
It was chosen because its extreme dryness and altitude offer excellent conditions for observing the submillimeter radio waves for which Alma was designed. What's more, the wide plateau at Chajnantor offers plenty of space for the array of antennas. The individual dishes will be spread out and linked together over distances of more than 16 kilometers.
The Alma antennas must withstand the harsh conditions at Chajnantor, with strong winds, cold temperatures, and a thin atmosphere with half as much oxygen as at sea level. This forbidding environment also poses challenges for the workers building Alma.
Although each of the antennas weighs about 100 tons, they can be moved individually to different positions in order to reconfigure the Alma telescope. Now this will be carried out by two custom-designed transporters. Each of these giant vehicles is 10 meters wide, 20 meters long, and has 28 wheels. Now that's what I call a monster truck. With Alma, astronomers will observe the cool universe, the molecular gas and the tiny dust grains that constitute the building blocks of planetary systems, stars, galaxies, and even of life itself. Alma will provide us with new and much-needed insight into the formation of stars and planets, and it will reveal distant galaxies in the early universe, which we see as they were over 10 billion years ago. I'm Dr. J, signing off for the ESOcast. Join me again next time for another adventure
High
in
on
the
the
far reaches of the
Chajnantor
universe.
Plateau in the Chilean Andes, the first antennas of the Atacama Large Millimeter Submillimeter Array, or ALMA for short, move in unison. Work progresses at a frantic pace in this ambitious project, which, in a few years from now, will consist of 66 antennas working together at an altitude of 5,000 meters. Once completed, ALMA will enable astronomers to study the cold universe in unprecedented detail. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory, exploring the ultimate frontier with our host, Dr. J, aka Dr. Joe Liske.
Hello and welcome to the ESOcast. In this episode, we're going to visit the Alma Observatory in the Atacama Desert in Chile. Here, ESO, together with its international partners, is building what will become the world's largest astronomical facility. Alma will observe the universe at millimeter and submillimeter wavelengths. This will allow astronomers to study both very cold objects as well as very distant objects in the early universe. Now, because such observations are disturbed by water vapor in the atmosphere, Alma is being built in one of the driest places on Earth, the Chajnantor plateau, at an altitude of 5,000 meters, which also makes it one of the highest astronomy sites in the world. Now, Alma will be operated at two distinct sites. First, there's the array operations site up on the plateau where the antennas are actually located. And then, further down, there's the operations support facility.
Constructing the Alma Observatory in the arid Atacama Desert and at such high altitude is no easy undertaking. When the antennas are brought to the high site, they must be assembled at the Operations Support Facility, or OSF. Located at 2,900 meters altitude, the OSF also serves as a control center for the antenna array, which is located at the high site. With majestic volcanoes looming in the distance, engineers are busy integrating and verifying the numerous parts of the antennas, and by now many antennas at various assembly stages can be found at the OSF. Each new antenna must meet very strict requirements. The surface of each dish is accurate to much less than the thickness of a sheet of paper, and the antennas can be pointed precisely enough to pick out a golf ball at a distance of 15 kilometers.
In many ways, the OSF has become the heart of the Alma project. This is where the staff live during their shifts and where much of the daily routine is going on. There are lots of meetings between various groups of scientists and engineers, and there are even scientific conferences that are being held at this remote location. The OSF also houses the two transporters that are used to move the antennas. So with the scientists and engineers assembling and testing the antennas and conducting the operations at the high site, the OSF has become a rather busy and vibrant place.
Scientists and engineers test the ultimate performance of the complex system. Pointing and holography tests are performed around the clock, and the experts make sure that only antennas fulfilling the tough Alma specifications get the green light. After an antenna has successfully passed all tests at the OSF, the time has come to move it up to the array operations site, which lies at an altitude of 5,000 meters. This was successfully done for the first time in September 2009. A giant custom-designed transporter is used to bring up the antenna. As each antenna weighs about 100 tons, this is a delicate task that requires the utmost attention. Two transporters are available, and they are also used to move the antennas to different positions to reconfigure the Alma array.
Of extremes, with strong winds, low temperatures, and a thin atmosphere. However, because of its extreme dryness and altitude, the site offers excellent conditions for observing the submillimeter radio waves for which Alma was designed. In addition, Chajnantor offers plenty of space. And that's needed because in its most extended configuration, the array of antennas measures 16 kilometers across. Despite the harsh conditions, work is ongoing to prepare the plateau for the antennas. A road network has been built, and the workers are busy with various tasks to finish the construction work. All of the 192 antenna foundations have been completed, and some of them are already in use. There's also a technical building which will eventually be used to receive the data from the antennas, to further process them, and then to transmit them down to the OSF. Now, as the number of antennas on the high site is constantly increasing, the project is moving into a new and important phase, that of commissioning and science verification.
Down at the OSF control room, the tension is high as the tests are performed. The commissioning and science verification process is intended to confirm that the whole facility has been taken from the stage where it was a collection of very complex parts into an instrument capable of producing images and measurements with exquisite sensitivity and precision. The antennas are placed at different positions within the array to make sure that all of their basic functions work correctly at different baselines. Currently, the antennas are located at the center of the site, using antenna stations that will eventually form the so-called Atacama Compact Array.
Alma is rapidly moving forward, and it holds a bright future for many areas of astronomy. For example, it will provide us with some unique insight into how stars and planets form, and it will be one of the premier tools to study the first stars and galaxies in the early and distant universe. And so, many of us astronomers simply can't wait to get their hands onto this fantastic science machine. This is Dr. J signing off for the ESOcast. Join me again next time for another cosmic adventure.